Hello everybody, welcome to Easy Intro to the Unit Circle. So today what we're going to do is we're going to talk about kind of how this thing over here, this unit circle, got constructed, what it is, how to use it, how to read it. In a future video, the one right after this, we'll solve problems using the unit circle and we'll actually use it in practice. For right now, all we're going to do is just describe it. Okay, so if you want to see examples of how to use it, look at the next video. So for now, we're just going to describe it. So what is it? Let me move my little face over here. So what is it? What exactly is the unit circle? Well, it is exactly that. It's a circle. So if we draw our x and y axis, so it's a circle on the x and y plane. Okay, so it is a circle. It's a circle with radius equal to 1. So if let's see if I can freehand this. We'll go to a computerized version. So it's a circle with radius 1, so centered at 0, 0. So this here would be the point 1, comma 0. This would be the point negative 1, comma 0. This would be the point 0, comma 1, because we can go 1 in every direction. And then this would be the point negative 1, comma 0. So that's all it is in essence. It's a circle with radius 1. But it is the gospel when it comes to trigonometry. If you can master this unit circle, you can master trig. Literally everything about trigonometry is just encoded into this unit circle. And all it is just a diagram. But out of this diagram comes so much information that if all you did was memorize the unit circle, knew how it worked, you could probably do 75% of all of trigonometry just by referring back to this circle. So it's huge. So anyway, back to it. So how it's constructed. So we use some popular angles like 30 degrees, 45 degrees, and 60 degrees, as well as 90 degrees, right? This guy here is 90, this guy here is 60, this guy here is 45 degrees, and this guy here is 30 degrees. And then we keep going. We reflect them over to the left. So this would be 90 plus 30. This would be 90 plus 45. This would be 90 plus 60. So basically we've mirrored image them over. So this is going to be 120. This is going to be 135. And this is going to be 150. 50. And then what is this guy here? This is 180. And where do we start? We start at 0. Okay, and we keep going all the way around. Okay, so again, plus 30, plus 45, plus 60. And then we get to 270. And then we keep going, plus 30, plus 45, plus 60. So it's always 30, 45, 60, 90. Plus 30, plus 45, plus 60, plus 90. Plus 30, plus 45, plus 60, plus 90. Plus 30, plus 45, plus 60, plus 90. Okay, all the way around. So the diagrams of degrees are here. Also, if we convert these to radians, the diagram in radians also exists. And all it is it's just a conversion from degrees to radians. So if I have 30 degrees, that's pi over 6. If I have 45 degrees, that's pi over 4. If I have 60 degrees, that's pi over 3. And if I have 90 degrees, that's pi over 2. Remember, pi is the length straight across. Pi is 180 degrees. So pi over 6 and 30, this is 1/6, right, of this half circle. Pi over 4, this section right here is 1/4 of the half circle. Pi over 2, right, this section right here is half of the whole. Pi over 3, this section here is 1/3 of the whole. So that's all radians is. Radians is literally just segmenting a circle. If we keep going, so this is 1/6, 2/6, 3/6, this is 4/6, or better known as 2 pi over 3. This is 5/6, 5 pi over 6. 135, that was a reflection of pi over 4, so that's 1 pi over 4, 2 pi over 4, so now this is 3 pi over 4. So all I'm doing is counting, and then this would be 4 pi over 4, also known as pi's. So the unit circle is split up into slices of sixths and slices of fourths. So you can count the sixths, right? 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6, 12, 6, because this is also known as 2 pi. Okay, same thing with the 45s. This is pi over 4, and pi over, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, which reduces down to 2 pi. So all we're doing all the way around is you're either counting by sixths, or by fourths. That's it. But that's all you have to do is count all the way around. Know that there's a pi over 4 in each kind of diagonal, and then there's 2 pi over 6s in each. And all you do is reduce, right? 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6, and reduce the fractions. So that's how you can get the degrees and the radians all the way around. The other thing that this unit circle has is it has the coordinates, right? This is a xy coordinate because we're on the xy plane. Well, what are these? Well, they're labeled all the way around. For instance, at pi over 6, this coordinate here is labeled at root 3 over 2 comma 1 half. At pi over 4, this xy is root 2 over 2 comma root 2 over 2. And at pi over 3, this is labeled as 1 half comma root 3 over 2. And these go all the way around. Now, the x coordinate, right, we went over we went over root 3, and we went up 1 half. For this coordinate here, we went over root 2 over 2, and we went up root 2 over 2, right, x comma y. For this coordinate here, we went over 1 half, and we went up root 3 over 2. And then for this coordinate here, we went over 0 and up 1. Okay, so with these dots here, there are the coordinates of these points, just the xy coordinates. What they also are, they are the cosine comma sine of this particular, I'm going to use theta, of this particular angle. Okay, so cosine of pi over 6 is equal to root 3 over 2. Sine of pi over 6 is equal to 1 half. So cosine of pi over 6 is equal to root 3 over 2. Sine of pi over 6 is equal to 1 half. So the unit circle also gives you these really popular angle measures for sine, cosine, as well as tangent. So the x coordinate here is the cosine of the angle. The y coordinate here is the sine of the angle, cosine comma sine. Think x comma y, right? Those are alphabetical. Cosine comma sine, also alphabetical, right? C comes before s. So that's a really cool thing about the unit circle. The other thing that you can get from the unit circle is also the tangent, right? Because tangent is equal to sine over cosine. Well, if sine is y and cosine is x, then tangent is really equal to the y coordinate over the x coordinate, which is also equal to the slope of this particular line, right? If we make this into a line, the slope of that line is also the tangent. So the tangent is the y coordinate over the x coordinate. So the tangent of pi over 6 then is equal to the y coordinate, which is 1 half, over the x coordinate, which is root 3 over 2. And if we compute these, we would get the tangent, right? Which this is going to end up being 1 over root 3, which when we rationalize the denominator, this will be root 3 over 3. Okay, so you can find cosine, sine, and tangent by examining the unit circle, okay? Let's look at now kind of how to read a couple of these. So how to read, oh, I gotta move my face again. So this is a much nicer unit circle. Oops, too far. So this is a much nicer unit circle. Okay, not to say that my weird looking circle wasn't nice, but so we can see here the degree measures are around here, and everybody's unit circle looks a little bit different, but the kind of elements that you could expect to find. You expect to find the degree measured. You could expect to find the radian measures. You can also expect to find the coordinates of each of the points around the unit circle, and sometimes as a bonus they give you the quadrant, right? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. And these little plus plus here is saying that the cosine coordinate is positive and the sine coordinate is also positive. Think cosine is your x coordinate, sine is your y coordinate. So in quadrant 1, right, we go right and up, so everything is positive, positive. In quadrant 2, we go left and up, so cosine is negative, but sine is positive, right, because x is negative and y is positive. In quadrant 3, we go left and down, so everything is negative, negative. So cosine is negative and sine is negative in quadrant 3. And in quadrant 4, we go right and down, so the cosine is going to be positive, but the sine is going to be negative. Okay? So what if I asked you, okay, what is the cosine of 2 pi over 3? Well, I go and I find 2 pi over 3, 2 pi over 3, 2 pi over 3. Oh, here's 2 pi over 3. The cosine, remember, is the x-coordinate. So the cosine of 2 pi over 3 is equal to negative 1/2. And done. There's no calculation to be done. I don't need to use my calculator. I don't need to use anything else. I simply read the unit circle. It's a diagram. Okay? What about if I wanted to do something like I wanted to find what is the sine of 3 pi over 2? Well, I go and find 3 pi over 2 on the unit circle. Where is it? 3 pi over 2. 3 pi over 2. Here's 3 pi over 2. And I look at the y coordinate because sine is the y coordinate. So I pick this out, negative 1. So then sine of 3 pi over 2 then is negative 1. And we're done. Okay, what if I wanted to pick out the tangent? So you can pick out sine, cosine, tangent. You can actually pick out all of them, secant, cosecant, and cotangent, which we'll see in a different video. But what if I wanted to pick out, okay, what is the tangent of, let's do 45 degrees, because I like this one. Tangent of 45 is what? Okay, well here's 45. All I have is the x-coordinate and the y-coordinate, but I know that tangent is the slope, which is the y over x. So tangent of 45 is equal to the y-coordinate over the x-coordinate, right? Y-coordinate, x-coordinate. What is anything divided by itself? It's 1. So hey, tan of 45 is equal to 1. Why is that? Because the slope of this line is positive 1. Which means the slope of that line is positive 1, which means the slope of that line is negative 1, which means the slope of that line is negative 1 also. So anything on a reflection of a 45 is going to be a 1 or a negative 1. So I really like these as tangents. So that's actually basically it about how to read this unit circle. And you can also see, like, if you're trying to pick out a quadrant of something, the quadrants are listed as well. If you're trying to pick out the sine of something, the sines are listed here as well. In a future video, we will go over some more explicit examples, and we can see what kind of things we can solve simply by knowing how to read the unit circle. Like I said, it's a very powerful tool. Oh, let me move my little head again. So I hope that cleared up any stuff. This is, again, just an intro video, so it was the very basic stuff about the unit circle. You can do a lot more than what I mentioned. There's a lot of things involved, like some Pythagorean identities. We can also do stuff with secant, cosecant, and cotangent. There's much more to be done with the unit circle, but that is simply the basics. So I hope you enjoyed the video, and I hope it helped.